Today we are looking at section 1.5, which is on measuring and constructing angles. So first of all, when we talk about angles, just like everything else in geometry, we need to make sure that we name angles correctly so that everyone knows what angle you're talking about. So there are different ways to name this angle right here that we see in the picture, and this angle right here. So one common, just to make sure there's no discrepancies, we use 3 letters, and the middle letter has to be the vertex, which, let's just explain what the vertex is. The vertex is right here, and right here, it's the point, okay? So we have the sides of the angle, and then we have the point of the angle, which is what we call the vertex. So we could call this angle CAB. So we have a point on one side, the vertex, a point on the other side. Similarly, we could call this BAC, angle BAC. Again, the reverse, point on one side, vertex, point on the other. Now, if there's no other angle it could be, like in this case, we could say angle A, because there's only one angle there. But if you have a situation where, you know, maybe your angle looks like this, and you want to talk about just this angle right here, well, you couldn't just say angle A because we wouldn't know which one you're talking about. And then finally, if there's like a little number in there, you could call it like angle 1. So those are the 4 ways to name an angle. And again, it's important to be specific, vertex in the center if there's 3 letters, so that everyone knows what angle you're talking about. So when you have an angle, these sides go on forever, right? And this is what we call the interior of the angle, and then outside the angle is the exterior of the angle. All right, pause the video and try these 3. And then you can go ahead and push play to see the answers. So for number 1, it says write 3 names for the angle. So we could call this angle Q, angle PQR, or angle RQP. There's no little number here, so we can't use that one. However, on number 2, there's actually 4 ways we can name that angle. So we could call it angle Y, angle 1, or angle XYZ, or angle ZYX. And for number 3, same thing. We could actually name it 4 ways. Angle E, angle 2, angle DEF, EF, and angle FED. All right, so now that we know how to name an angle, let's measure an angle. So to measure an angle, I'm going to zoom in here on this protractor. So notice on the outside, right here, the outside numbers start here. But then the inside numbers start here. So you start with 0 and you go up from there. Now, we know things about angles. We know that if we have a right angle, that didn't do it. If we have a right angle, maybe it doesn't do right angles. Well, if it's a right angle, that's 90 degrees. And if you have a straight angle, which we're going to talk more about in a minute, that's 180 degrees. So we know, looking at this angle right here, it's bigger than 90 degrees. Right? We know it's bigger than 90 degrees. So don't use the wrong numbers. We want to start here at 0, and we're going to measure from there, and notice it goes to 140 here. So this angle is 140 degrees. We'll call it, we'll call it angle O is equal to, the measure of angle O is equal to 140 degrees. So we're going to get more into that in a minute. But the measure of that angle is 140 degrees. And so when we're talking about measure, we say equal, and we put that little M in front to be measure. If you accidentally looked at the 40 here instead, Well, hopefully you know that's not right, because again, looking at that angle, you know it's bigger than 90 degrees. Let's talk about some types of angles, and we're going to get some more practice measuring. So if your angle is in between 0 and 90 degrees, okay, not equal to, then it's an acute angle. As we just said, if it is exactly 90 degrees, then it's a right angle. If it's in between 90 and 180, it's obtuse. And a straight angle is exactly 180 degrees. So we're going to be measuring and classifying these angles here. So I'm going to use my highlighter to, I'll keep it on red. I'm going to use my highlighter to highlight the angle here. So G, see that's one side. Oh, I need to make my highlighter bigger. Let's try that. So G, H, K. So it's this angle right here. And we can see it is bigger than 90. So we're measuring this angle right here. And so we're gonna start at 0 on these outside numbers. And notice it's between 120 and 130. So right there, it's 125 degrees, right in between. So I'm gonna go back here and I'm gonna say 125 degrees. And then we would say this is an obtuse angle. All right, so next, I'm gonna clear all that out. And so now let's highlight JHL. So JHL is that one right here. And we can see that is 90 degrees. So that is 90 degrees, and it's a right angle. And then finally, we have, let's clear that out. And finally, we have LHK. So LHK. Ooh, this one's in between. So notice it goes from, let's see. Well, we know it's an acute angle. We know it's less than 90. So it doesn't matter what numbers you use, but use the same ones. You could either use the outside numbers and say it's between 125 and 90, or you could use the inside numbers to say it's in between 90 and 55, okay? But what we're gonna do is we're gonna find the difference between those two numbers. So 125 minus 90 is 35 degrees, and 90 minus 55 is 35 degrees. So no matter what numbers you pick, you get the same answer. So it's 35 degrees, and it is an acute angle. All right, so just like segments, two angles are congruent angles when they have the same measure. So if we have angle, we'll just say angle 1 congruent to angle 2, then that means that the measure of angle 1 is equal to the measure of angle 2. So notice when we include measure, we use equal, and we use that little m to indicate measure. All right, so now we're going to get our toys out, and we're going to construct a congruent angle. So we're going to start with the compass, and we're going to put one point right there, and we're going to not make it too big or too small, but set it at a measurement where you can draw like an arc about that far away from the point. Okay, so we're gonna make that arc. Now in the meantime, we're gonna use our straight edge, and we're gonna make our like bottom side of the angle. So without moving the compass, it's still that arc measurement that you made this arc with. You're gonna make that, you're gonna put the point right there, and you're gonna make the same arc on that one. And just like we used our compass to measure, we're gonna measure on our initial angle. So what we're gonna do is we're gonna take our compass and we're gonna put one point right there, and 1 point right there, and here's our compass, and we're going to measure that opening of the angle. And notice, you know, both these points are the same distance away from the vertex, just like that's the same distance away. So we're going to measure that opening, and then we're going to come over here and measure that same opening and make a little mark there. Using our compass, we're going to measure the same opening and make a little mark. And so we know this angle is going to have the same, you know, the same distance away from the vertex. It's going to have the same opening. And then we can use our straight edge to draw the other angle. Now, look, mine doesn't look congruent because I'm not using a compass and a straight edge, but I'm teaching you the directions or the method to do it. So there's another one for you to practice here on your notes. You can always borrow the tools in class. So finally, we have the angle addition postulate. And just like segment addition, it's a postulate, so we don't prove it. We're just like, okay, that makes sense. And so when we have two angles together, notice we have this angle and this angle that have a common side, right? They have a common side. Then the angle RSP plus the measure of angle PST is equal to the measure of the whole thing, which makes sense, right? They're right next to each other, just like when segments were next to each other. So we're going to use that property to, okay, that's it. So we're going to use that property to find the measure of JKL. So JKL, oops, I didn't mean eraser, I meant highlighter. JKL is the whole thing, see? We want to measure the whole thing. So the measure, we'll go back to pencil. The measure of angle JKL is going to be equal to 31 plus 85, which will add up to be 116 degrees. Now here we have angle, it says measure of angle RSU is 90. So this whole thing is, 91 degrees. The whole thing is 91 degrees. We know this part is 69 degrees. We're going to call this part X. That's what we want to find out, angle RST. So just like with the segments, whatever we want to know, that's going to be X. So notice from the segment or angle addition postulate, we know that X plus 69 has got to equal the whole thing. So the two small parts added together have to equal the whole thing. So we're going to subtract 69 from both sides. X equals, let's see, 8, 2, 2, 22 degrees, which is equal to measure of angle RST. Finally, maybe it can get a little more complicated, like the segment ones did, and involve X as part of the problem. So we know that this angle plus this angle have to equal the whole thing, and the whole thing is a straight angle. So whenever you see a straight angle or a straight line, you're supposed to know that that's 180 degrees. So our equation here is going to be the one angle plus the other angle is equal to 180 degrees. And so that's going to give us 2x plus 20 equals 180. Subtract 20 from both sides. 2x equals 160. And then, here we go. And then dividing both sides by 2, we get x equals 80 degrees. Now, what did we have to find? It says, find the measures of each of those angles, right? So now we got to plug it back in. So let's see, the measure of XWV is X. So the measure of angle XWV, which is this one right here, is X. So it is 180 degrees. Oh, not 180, 80. Whoops, 80 degrees. Or we can even do it right here. This one's 80 degrees, and 80 plus 20 will be 100. And see how the 100 and the 80 add up to 180? So finally, the measure of angle UWV is equal to 100 degrees. And that's it.